on the issue of combined event and tree diagram. But before we start the lesson, I would like to advise you to have a chair and a table, and if possible should have a notebook so that you can take some notes on what we are discussing. I would advise you to have a comfortable place for study so that you can digest all the materials effectively. Thank you for hearing my advice. As I said, today we are going to discuss the third lesson, which is combined event and tree diagram, on the same topic of probability. This is a third lesson. Now, what are the combined event and what are the tree diagram? Actually, we discuss the one side of one aspect of probability, that is an event can occur to a certain uncertainty. But there is another side, there is another aspect where you may have two outcomes. In such cases, if there is a possibility of two events to occur at a time, we call them combined event. That means you can put all of them together because they can occur all together. What we are saying that if two or more simple events may occur or take place at the same time, and you can represent as a single event, those events are called combined events. For example, here I have 2 coins. I have 2 coins. These are coins. When I toss them in this way, observing that on one coin you can see a tail. This is a tail. And on another coin we can see a head. This is a head. So a head and a tail occur at the same time. As on the first case, we toss 2 coins and we have observed that on one coin a head appears and on another coin a tail appears. But let's again try for the second time to toss and let's again observe the outcome. For example, I toss again. This one. Yes, observing that on the first coin we observe the head, and again the second coin we also observe the head. So it is possible when 2 coins are tossed, you can observe the same data on both coins. Now, for example, if we consider that when we toss 2 coins, the head on the first coin and the head on the second coin appears, that should be our outcome of interest. We can say that there, since we observe two outcomes. On the first coin, let's name by using E1, subscript 1. That should be what? The result of obtaining a head on the first coin. And another result on the second coin, let's call it E2. E2 it should be equal to the result of obtaining a head of the second coin. Then, since these 2 outcomes occurs at once, it can be represented by a single event, which is called E. And by that case, E is the combination of 2 events, that is E1 and E2. You have to know that the possibility set and events for combined events can be found by using tree diagram. That's where we introduce the concept of tree diagram. So if someone asks you what is tree diagram on probability, this actually is the way of finding the possibility set and sometimes even the events, but when 2 or more events can occur at once. But also we prefer tree diagram. There are other ways of finding the possibility set, which we can use table of combination. For the above examples, we said when two coins are tossed together, the possibility set can be found by tree diagram as follows. Yes, since we have two coins, we are going to separate them, but we must show the starting point. This is the starting point. We start to express the first coin, the outcome of the first coin, which is this one. We know that there are two possible events. We can either observe a head or we can observe a tail. This is the case for the first coin. But again, since we have the second coin, and we know that when it appears a head on the first coin, does not hinder the occurrence of a head again on the second coin. Therefore, here, for the first coin it can appear head, and again for the second coin it can appear again a head. But appearing of a head on the first coin, it can go with the appearance of a tail on the second coin. So this one, there are also two possible outcomes which can occur, which is a head and a tail. This is for the second coin. But again, if on the first coin you observe a tail, this one does not hinder the occurrence of a head on the second coin, or does not hinder the occurrence of a tail on the second coin. Therefore, here we can also have two outcomes on the second coin, that is, it can be a head or a tail. Then, in total, here the sample space, it will be the set of one of the events can be either a head. Since we said we can record these two events as the single event, so then by recording as the single event, so it can be a head, the first event. But it can occur in a way that it is a head and a tail. That means on the first coin you observe a head, and on the second coin you observe a tail. So it can be head, tail. And again, you can observe a tail on the first coin, and a tail on the first coin, and a head on the second coin. So it can be TH. And the last outcome which we can observe with that, from the first coin you can observe a tail, and again on the second coin you can observe a tail. So it will be TT. Simply, if you have a tree diagram, actually this is a tree diagram. If you have a tree diagram, how to get the sample space and the event, what you do, you make a path along the, you make a single event along the path. For example, this one to be the first path which makes a head, and this one to be the second one which makes a head and a tail. Similar to this one to be this one and this one, and again this one and this one. So this one makes the sample space. That's the way we can use a tree diagram on getting the sample space and also the event. This is the case for the sample space. As on the first approach, we said we can use a tree diagram, and we said that is the preferred one. But we can also have another way of finding the sample space and sometimes the events. On this another approach, we normally use the table of combination. Actually, here we have the first coin on this side, and again we'll have the second coin on this side. Therefore, we know that for the first coin we have two which is either a head or tail. And also on the second coin, it can appear a head or tail. Then we join this way. We construct the table this way. Then and this way. Then what we'll be doing here is to combine now from the first coin and the second coin. As we said, on the first coin it can appear a head, but also on the second coin it can appear a head. So with that it will be head, head. Then again on the first coin it can appear a head, but on the second coin it can appear a tail. So it will be a head, tail. And again on the first coin it can appear a tail, but on the second coin it can appear a head. So it will be T-H. Again, on the first coin it can appear a tail, while on the second, but also on the second coin it can appear a tail. So it will be T. This is the way of finding the sample space by using the table of combinations. As I said, we prefer more the tree diagram, but also this one it can be applied. It depends on the nature of the information that you have. Sometimes you may find that it is tedious to use a tree diagram, therefore you advise it to use a table. But in some cases you find tree diagram is very precise compared to the tabulation. But then it gives the same results. Okay. Now let us have an example on the combined event. And here the example it says a die and a coin are tossed together. A die and a coin are tossed together. Draw the tree diagram to find the sample space and hence determine the probability that a head and a number less than 3 will occur. The example is the question says a die and a coin are tossed together. We are going to draw the tree diagram to find the sample space, but also we are going to determine the probability that a head and a number less than 3 will occur. Let us see. But before that, you should know what is a die. A die actually, it is a keyboard like this one. This is the keyboard. Normally, it has 6 faces. I'm not saying this is a die, but it is the same as the die in terms of shape. This is a keyboard. It has 6 faces as a die it is. Normally, a die, it is numbered from 1 to 6. For example, here, I use the dosi to number this size of the keyboard so that it matches to the die the way it is. I numbered here 1 and again 2, then 2, then 3. You see 3 dots, then again 4, then there is 5 here, and again we have 6. That's the way die it is. So a die, it has 6 faces, numbered from number 1 to 6. But the question says we should toss a die and a coin. A die and a coin. We can toss them together. To toss, it is like to do in this way. This is yes. Then to find the sample space by using the tree diagram, it can be done in this way. As usual, we must have the starting here. But we should decide whether we start with a die or we start with a coin. Which event should be started to be displayed here. Let us start with a die. A die, as we said, it has 6 numbers. They are numbered from 1 to 6. Therefore, when you you can either observe 1, or you can observe 2, or you can observe 3, or you can observe 4, or you can observe 5, or 6. This is 6. These are the numbers that you can observe from the die. Since it has 6 numbers, and according to the way we define the probability, we say it works under a fair condition, and therefore here each number it has equal chance compared to the another. Therefore it can be either 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. This is a die. This is a starting point. But again, we can have the outcome on the coin. We have the outcome on the coin. As we said, on the die it can appear 1. But this one, or on the coin it can appear as a head or a tail. Since we say the verse of the coin is either a head to appear or a tail to appear. This is a head. This is a coin. A coin. We have a head or tail. This is the case for the first case, that when in a die it appears 1, therefore in the coin can appear a head or a tail. When on the die it appears 2, then on a coin it can appear as a head or a tail. Again, when on a die it appears 3, on the coin it can appear a head or tail. Similar, when on the die it appears 4, then again here we can observe as a head or a tail. As usual, when it appears 5 on a die, on a coin it can appear a head or tail. But also on the last possible number which can appear on a die, which is 6, it can go with a head or tail. Therefore, the sample space S, it will be the set of, we said we are making the result by using the pass. So the first pass will be by using 1 head. The second one will be by using 1 tail. Then again we'll have this one 2 head. 2 head. Then we'll have 2 teeth. Then again we'll have 3 head, and again 3 teeth. We'll have 4 head, and again 4 teeth. But also it can be 5 head and 5 teeth. We have also 6 head and 6 teeth. So these are the all possible outcomes that you can observe when a die and a coin are tossed together. Yes, our sample space is this one, but according to our question, we are also required to find the probability of event when a head and a number less than 3 appears. Then because we are going to deal with also the probability, we must know the number of element of the sample space. And here we use NS. This is the number of sample space. This one will be equal to. What we do, we count the number of all outcomes in the sample space. And here we have the first, the second, the third. Then here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The total number of outcomes is 12. So here the number of sample space it will be 12. But again, we should know the event. And on the question, the event is a head and a number less than 3 appears. Then here the event it will be equal to the set of, we should take the event which are combined with a head and a number less than 3. Observing here, this is 1 and the head. It has set it to our event because 1 is less than 3 and also it is combined with the head. So we have here 1 head. And again, this one, it is not a man, since here we have T. Then here we have 2 head. 2 head, it has set it, since 2 is less than 3 and it is combined with a head. And again, this one is 2T. It is not a man because it is combined with T. Then here 3H, it is not a man of, since we have been told that it should be less than 3. Observing the other outcomes, you find that either a number is bigger than 3 or equal to 3, or it is combined with the unrequired outcome on a coin. So the event is this one. As usual, since we are going to find the probability, we must know the number of the event. Here we count. So number of event, it will be equal to, it is 1 and again 2. So we have 2 events, 2 outcomes. So it will be, the number of events equals to what? Equals to 2. And as I said, we are going to find the probability. Therefore, a probability of event, which is to get a number less than 3 and a head, it will be equal to number of event over number of sample space. But what is the number of event? In our case here, the number of event is 2. So it will be 2 over the number of sample space. The number of sample space is the total outcome, which is what? 12. Then try to simplify here, since 2 and 12 can be simplified both by 2. If you simplify here, you get 1 over 6. Then here, the probability of getting a head and a number less than 3, it will be equal to 1 over 6. Let us see again the second example on the same concept. And this example, it says a fraction is written by selecting the numerator from the degrees 1, 2, and 3, and the denominator from the degrees 6 and 8. Again, a fraction is written by selecting a numerator from the degrees 1, 2, and 3, and the denominator from the degrees 6 and 8. We are required to draw the tree diagram to find the sample space. And again, we are going to find the probability that a fraction written is less than a half. So we have 2 ways here. The first is to draw the tree diagram to find the sample space. And again, we will be required to find the probability of writing the fraction which is less than a half. First, we need to recall the concept of fraction. Normally, a fraction, it is a number which can be written in form of A over B. That should have a numerator and it should have a denominator. It can be written in form of A over B. This A, it is called a numerator. And this B, it is called a denominator. Then from this one, from our question, it says for numerator. For numerator, we have to use numbers which are 1, 2, and 3. And for denominator, we have to use the numbers which are 6 and 8. And for this one, if you want to write the fraction, that means the first one can be 1/6. We take 1 digit on these 3 digits, and we use 1 digit on the second set of numbers. So it can be 1/6, it can be 1/8, it can be 2/6, and again it can be 2/8. Similar again, it can be 3/6 and 3/8. I think these are the possible fractions that can be made by using these digits from the set, which are used only for numerators, but also the second set, which is 6 and 8, which is used for the denominators. But we are going to draw a tree diagram, since our question says we should use the tree diagram. And I said if we want to rewrite the fractions to be like this one, but according to the condition of the question, we need to use the tree diagram. Here, let's have a tree diagram. We must think the starting point. And again, we should decide which we should start with. And again, we should join to the second one. So, for example, if we decide to start with the numerators, so here we write here numerator. We know that the numerator can be formed by using either 1, or it can be used by using 2, or it can be made by using 3. These are the digits which are used for the numerator. As we can see here, the numerators are 1, 2, and 3. But this one must be combined to the denominator, to the digits either 6 or 8, so that it can make the fraction. So a 1 can be made with either 6 or 8. And again here 2 it can be made with either 6 or 8. Similar to this 3, it can be either made with 6 or 8. But this is the case for denominators. Then the sample space here, it will be equal to the set of the first part, it is 1,6. The second, it is 1,8. The third one will be this one, 2 and 6. 2, 6. And again, can be 2,8. And again, it can be 3,6. And it can be 3,8. These are the sample space. Or someone can rewrite the sample space in terms of the fraction at this one. So you can use this one because we are making the pass. So you can take 1 and 6. That means 1 should be used for at the numerator, while 6 should be used at the denominator, and therefore the fraction should be 1/6. Similarly to the second one should be 1/8, 2/6, 2/8, 3/6, and 3/8. Then from this one, we should know the number of sample space.